Hi everyone, it's Anna here and I'm ready to sprinkle some tech sparkle into your life. In this video, I want to talk about system calls. In this video, we'll cover three exciting parts. First, we get a big picture of the privilege levels and understand why they're essential for the system security. Next, we're going to go step by step through how a write system call travels from your user application to the kernel side and then back. And finally, we'll bring it all together with a hands-on example using C++. Are you ready to dive in? Let's go. Okay, so imagine your computer has two main zones, a user space and then a kernel space. User space is where all your applications run. It has a privilege level of 3, and rank 3 is the lowest privilege level. While a kernel space is the protected area where the kernel operates with a privilege level of 0. 0 is the highest privilege ring level. Has an unrestricted access to all the system resources, including hardware and memory. It can execute any CPU instruction and access any memory location. Since the kernel mode has a full access, any bugs introduced in this mode can crash your entire system, while Ring 3 has a limited access to the system resources. Programs running in user mode cannot directly access the hardware and memory used by the kernel. If an application crashes, it will typically only affect itself, not the entire operating system. Instead, they use, yes, you guessed it, they use a system call to request help from the kernel. For example, when your program needs to write data to a file, it makes a system call to the kernel to perform this action. Okay, you might be already familiar with some of the system calls like read, write, open and close, and these functions request the kernel to perform tasks like reading and writing to the file. Let's check how the system call works under the hood now. Okay, and we can concentrate on our write system call. Let's first divide our working space into two sections, a user space and a kernel space. User space is where your applications like a text editor and a web browser run. I will show you how the system call write can make it from your app all the way to the kernel and write a message hello into the file. Our program will call the write function and it takes several parameters. The first one, okay, a file descriptor, then a buffer, and finally it takes the size of the string that you're trying to write to a file. And a write function defined in the glibc. Glibc is a core part of the system and it is responsible for providing the C standard library function. Glibc contains a wrapper function for the write system call. This wrapper prepares the call to the kernel by putting all these parameters into different registers. Okay, well, for example, write system call can be identified as 1. And it depends on the different system, but we can put it in a register EAX, and we can put other parameters into EBX, ECX, and ADX. And now we are ready to send our parameters over to the kernel side by using a system call. Glibc uses a system call instruction to transition from a user mode to a kernel mode. Think of a system call as a bridge between the application and the system hardware and a core function. Here we have our beautiful bridge here. The kernel has a system call interface, which is the entry point for the system calls from user space. System call interface will save the state of the CPU and values of the registers. Okay, so here's our system call interface. And system call interface is connected to the kernel that has access to all the hardware like CPU, memory, drivers, and the disk. And so what the system call interface will do is just, it will identify our system call number and we'll save it and extract other parameters from the appropriate registers. And then through the system call table that maps system call numbers, and it will map them to a corresponding kernel functions. And then it will execute the appropriate function, like, for example, write is associated with 1, and so then the kernel is going to know that 1 is for the write function, and it will perform the write operation. And this is how the write is executed. But guess what? We are not done yet. Oh, why not? The kernel function now can return a value back to the register, and then kernel restores the save state of the user space process and transition back to the user mode. And this is how it's done. Now ready to check out the example? Okay, let's do it. Okay. Let's first define our string, and we can say hello as our string, and we need to save it as a pointer. Okay, and then we need to save our file descriptor and use the open function to open our file. Okay, so the first parameter is the string with a path to our file. Then we need to say that we can open this file for writing. If the file does not exist, we want to create it and give reading and writing permissions to it. Okay, and now we are ready to use our write system call. The first parameter is a file descriptor, then it takes our buffer and a string length of the buffer. Okay, and we can close the file now. Okay, just put a file descriptor in. Okay, and now we can compile and run our program, right? Let's compile it first. Okay. Okay, now we can run it. Okay, here you go. Now we can see that we have our string written in our text file. All right, and there you have it. Didn't I just sprinkle some text sparkle onto you, and we'll learn how the system call works together, and even wrote some C++ code together. If you enjoyed this video, don't forget to like and subscribe, and leave a comment below if you have any questions or want me to cover any other topics. Okay, until next time, keep shining bright and coding with confidence. Bye-bye!